Assalamualaikum and salam sejahtera. Before we proceed with our lecture part 3, let us recall a little bit on what we have learned in the previous lecture. Okay, so we know that complex number, okay, denoted as Z, can be written as E plus BJ. Okay, so some books they use I, some books use G. Okay, which referring to imaginary part, and this is your real part. Okay, real part of your Z. This is imaginary of your Z here. Okay, so B is the real number of the imaginary part. Okay, real number, but this is your real part only. Okay, right, so this is called standard form of complex number. Okay, so this is the common way of writing complex number. Okay, in terms of knowing, we want to know the position of complex number, you can plot an Argand diagram. Okay, where this is always your x-axis is your real part, and y-axis is where you plot your imaginary part. Means you plot your B in this y-axis. Okay, so this is called Argand diagram. Argand diagram. Okay, right. So this is the first form of writing complex number. Right, besides standard form, you also can express, okay, represent complex number in polar form. Okay, so in polar form, okay, we write complex number in a trigo function. Okay, trigonometric function. So our Z, okay, is written as cos theta plus j sin theta. Okay, so here you need to find your R, where R is the modulus of your Z, okay, or your radius, okay, radius from the origin to your point Z, okay, where Z is at point A, B here. So this is where your R is, okay, so radius or length, okay, where it is equivalent to A squared plus B squared, okay, while theta here is the angle from the x-axis, so the angle, okay, of your straight line to the x-axis following the anti-clockwise. So this is your theta, and theta is called argument Z. Okay, your theta, which is equivalent to arctangent of B over A. Okay, so that's it, right? And the third form is exponential form, okay, where we write our Z as R exponent theta G. Okay, so that is why it is called exponent form, because we write it in exponent. Okay, so here this in exponential form, okay, theta is in radian. Okay, in polar form, theta is in degree. Okay, so you check back your previous slide on this. Okay, I have mentioned in details about radian in degree, theta in degree and theta in radian, right? Okay, and now, okay, we are going to apply all this form, okay, to the next slide. Okay, what we have learned in the previous slide, now it's time for us to apply. Okay, now let's move to the first slide. Okay, so it is about the Moivre theorems. Okay, the Moivre theorem is the theorem that is us to find the power, the complex number to the power of n. Okay, where our complex number z is expressed in polar form. Okay, so the condition is it is expressed in polar form, and then you can apply the Moivre theorems. Okay, um, just a simple ideology, all right? So imagine that you have a z to the power of 2. So means here your n is equal to 2. Okay, and when you express in polar form, okay, let's say your r is 2, okay, 2 to the power of 2, and you have cos 30 plus I sine 30 degree also to the power of 2. Okay, so if it is just a small power like 2, you can just expand it as usual, right? Like 2 to the power of 2 become 4, and then that become 2 times of you multiply the same term here 2 times, right? Because this term is to the power of 2. So you can still expand this and perform the multiplication, right? It is still be within your capability to do it. All right. So can you imagine if your z is to the power of 10, where your here means your n is 10. What if your n is 100? Are you willing to multiply it for 10 times? Okay, if you have like n to the power of 10, so you need to do cos 30 plus I sine 30 power of 2, okay, to the power of 5, so you get n equal to 10. Are you willing to do that? You can, but it consumes a lot of time and a lot of effort there. It becomes very complex. Alright, so here is where we apply the De Moivre theorems to help us to find z to the power of n, where n is assumed to be very large lah. Okay, even though it is as small as 2, you can still apply the Moivre theorem. Okay, as long as your z is to the power of n, to the power of anything, any power. N can be fraction, n can be whole number, okay, and also can be negative number, negative integer, and so on. All right, so you must understand the concept of the Moivre theorems. Whatever the n is, you will have no problem to deal with the question. Okay, so what does the Moivre theorem tell? The Moivre theorem say, okay, if your z is to the power of n, so if your trigonometry punya identity is to the power of n, which is this part, okay, right, to the power of n, that is equivalent to cos the n you multiply to the theta, n you multiply to the theta, and this n you apply to this theta. That's it, as simple as that. The Moivre theorem say if your trigo term, okay, to the power of n, you just multiply the n to the theta, to the angle. That's it. Okay, and for your r, whatever the power of z is, your r also follow. Okay, so in full, all right, if z to the power of n, okay, your r is to the power of n, okay, the trigo term is to the power of 10, Okay, when we apply the Moivre theorems, okay, so this part change to that. Okay, now it becomes simple, right? Okay, let us look at example 1. Okay, alright, so let Z be this. Okay, now you need to find Z to the power of 5. That means it's Z5. Okay, once this is Z5, everything here will also power 5. So to the power of 5, and all the term inside the bracket here will also be power 5 like that. Okay, so if we want to apply the on common ways, we need to multiply the term in the bracket for 5 times. Okay, so we don't want to do that. Okay, we just apply the De Moivre theorem, so it will be more easier and more simpler. All right, so applying the Moivre theorems. Okay, so now our Z will be 2 to the power of 5, that is 32. Okay, so all the term inside here, okay, by applying the Moivre theorem, so 5 will be multiplied to the angle, and this angle. So what we have now is cos 5 multiply 45 degree plus I sine 5 multiply with 45 degree. Okay, so that will simplify 32 cos 225 degree plus I sine 225 degree. Okay, so you can apply directly the degree into your calculator. Okay, so when you substitute cos 225 into your calculator, you will get negative square root of 2 over 2, okay, minus I square root 2 over 2. Okay, so that will simplify to 32 divide by 2. Sorry, I said 2 but I write 6. Excuse me. Okay, divide by 2. Okay, and we also factor the negative out. Okay, and we factor the square root of 2 out. Okay, so what we have inside is only 1, okay, plus I. Okay, and you will get, okay, this one cancel with that, this 16 square root of 2, 1 plus I. So that is the answer. Okay, so one more way, if you do not want to apply, do not want to substitute the angle into the calculator, you can use the special angle, but you need to check first. Okay, what you need to check is in the Argand diagram, where is 225? 225 is 180 plus another 45 degree. Okay, so plus another 45 degree, that will give you total 225 degree. Okay, so it is in the third quadrant. Okay, only tangent that is positive in the third quadrant. Okay, so we have cos here, sine here, so you must remember that you must include negative to your value. Okay, so that's why if you see here, it is negative value, it is negative value. Okay, it is safer to use calculator. But in case you do not have the calculator, your calculator die out of battery and so on, okay, things that it can help you is the fundamental of mathematics. You're strong in the fundamental, you have no problem, okay. So that's why I always show all the possible method or the possible ways that my student can use. Okay, so 45 is the spatial angle, remember? So if that is 45, this is 45, and this is 1, this is 1, you will get the hypotenuse is equal to square root of 2. Okay, so what is, okay, so now we apply the second method to the power of 5, 32 will remain 32. Now cos 2 to 5. Okay, so cos 2 to 5 here. It is 45, right? So cos is adjacent to the hypotenuse. Adjacent is 1, hypotenuse is square root of 2. So don't forget to include negative 1 over square root of 2. It is negative because cos in the third quadrant is negative. Okay, so it is plus another 45, but for sine is opposite over the hypotenuse. Okay, also negative value. Okay, negative 1 over square root of 2. I don't forget. Okay, so this will simplify to 32 over square root of 2. Factor the negative out, and so negative. So when you factor negative out, you have 1 plus I. Okay, so don't worry, it does not equal to this, right? So what the what we need to do here is, you can leave your answer in this form. This is also correct. Okay, if you want to simplify more, okay, you need to multiply with okay, now you need to multiply with square root of, you multiply with square root of 2. Okay, square root of 2, square root of 2. Okay, don't worry, if you multiply with square root over square root 2 over square root 2, this mean nothing. This just mean 1. So actually, you just want to simplify things, and it does not affect your value, does not affect your answer, because what you are doing now, multiplying to the new term here, which is square root over square root 2 over square root 2, it is actually 1. But we introduce square root 2 over square root 2 just to simplify this. Okay, we do not want the denominator to be the square root. Alright, so we multiply with this term. Okay, where this term is just mean 1. So you multiply anything to 1, it does not affect the value. Alright, alright, so now you can simplify things where this multiply with that is equivalent negative 32 square root 2, okay, over square root 2 multiply with square root 2, that will give you 2, and the term in the bracket remain. Okay, now you can, now if you see what we have here is equal to that from the first method. Okay, so cancel this. You see, you still get the same answer, which is negative 16 square root of 2 multiplied with 1 plus I. Alright. Okay, for this example, I will show you just one, okay, and I will leave the remaining example for you to try, okay. So I'll show you B2, okay, B2. So please do B1. Right, so for B2, alright, so we write Z is equal Z to the power of 6 minus 1 plus 3i to the power of 6. Okay, so we apply the Moivre theorem. De Moivre theorem. But before we apply this, okay, first we need to transform this. Transform to polar form. Okay, so we need the R. So here, from here we know A is -1 and B is 3. Okay, here you need to know that this is your original Z only. Okay, so your Z only is -1 plus 3. Now the question asks you to find Z to the power of 6. Okay, Z to the power of 6, where this is only your Z. Okay, so to the power of 6. So based on this, okay, you transform first to polar form. Okay, so your A is -1, B is 3. So to transform to polar form, you need the R. Okay, so it is -1 to the power of 2 plus 3 to the power of 2. That will give you square root of 10. Okay, then you need theta. Theta is tangent B. B is 3. A is -1. That if you substitute into calculator, you get -71.565. Okay, where this, if it is in the Argand diagram, it is in the second quadrant. Okay, it is negative here because it is here. Okay, it is the small angle following the clockwise. Okay, but that's why it is negative 71.65, sorry, 565 degree. Okay, where actually the theta is equivalent to, okay, 180 minus 71.565. That will give you, okay, equivalent to 108.43 degree. Okay, so angle negative 71.565 equivalent to 108.43. So it is up to you later which angle do you want to apply and use for your sine and for your cos. Okay, both should give you similar answer. Okay. Okay, now we can apply our De Moivre theorems where z to the power of 6 is equivalent to R. Okay, first we write this. Our new Z in polar form is square root of 10 cos 108.43 plus I sine 108.43. Or you also can use Z equals square root of 10 cos negative 71.565 degree plus I sine negative 71.565 degree. Okay, so I will use this form. Okay, apply into the Moivre theorem. Okay, so Z to the power of 6 means your R here will also power 6. So square root of 10 power 6 and everything here. Your cos 108.43 plus I sine 108.43. Excuse my handwriting, okay, because it is not stable by using this writing pad. Okay, so this is also power 6. When you apply the Moivre theorem, now it become, okay, square root of 10 to the power of 6. This is 1000. Okay, so cos, your angle will multiply with 6, right? So you have cos 6 multiply 108.43 plus I sine 6 multiply 108.43 Okay, close the bracket. That will give you 1000 cos 650.61 degree plus I sine 650.61 degree. Alright, if you substitute into your calculator, you will get 1000. So cos of 650.61, that is 0.352. Okay, plus with I, and sine of 650.61 will give you a negative value of 0.936. Okay, so when you multiply, solve for that, you will get 352 minus with I 936. Okay, I. Okay, so I leave for you B1 for you to try.